What is El Niño? How is it going to affect the mankind? When will this phenomena occur? And what should you know about it? Today, we embark on an enthralling journey to explore the fascinating phenomenon known as El Niño. Life on Earth is a symphony of cyclical variations, from the rhythmic dance of day and night to the graceful transitions of the seasons and the ebb and flow of tides. Many of these changes occur predictably over short periods, but some cycles impact our planet over larger intervals and prove challenging to forecast. One such climate cycle that significantly affects us is the El Niño Southern Oscillation, commonly referred to as El Niño and La Niña. Though they originate in the Pacific Ocean, their consequences are felt nearly everywhere on Earth, and, alarmingly, the strongest effects are becoming more frequent. In recent decades, we have witnessed the destructive consequences of El Niño and La Niña, including flooding, drought, famine, and mass die-offs of marine life. A severe El Niño in 1998 triggered a cataclysmic mass bleaching event, causing an estimated 16% of the world's coral reefs to perish, leaving a devastating impact that still lingers today. The global reach of ENSO ensures that it will undeniably impact all of us. So, what exactly are El Niño and La Niña? How are they interconnected, and what are their global ramifications? Join me, Alex McColgan, as we delve into this captivating climate cycle that has been shrouded in legend long before science could explain it. The intriguing name, El Niño, has its roots in folk tales. Fishermen in the 17th century observed periods of warmer waters and poorer fishing conditions that peaked around Christmas time. They fondly referred to this phenomenon as El Niño de la Navidad, meaning, the boy of the Nativity, or, the Christmas child. It wasn't until the late 19th and early 20th centuries that scientists began connecting seemingly unrelated regional events scattered across the planet. As they pieced together the puzzle, it became clear that these events were part of a grand global cyclical phenomenon known as the El Niño Southern Oscillation. The ENSO fluctuates with an average interval of 5 years, though its cycle can vary between 2 and 7 years. While we have been tracking these cycles for decades, they have existed for much longer. To grasp why the El Niño Southern Oscillation occurs, let's examine the normal conditions in the Pacific Ocean. Trade winds blow from east to west along the equator, a result of the Coriolis Effect caused by the Earth's rotation. Remarkably, if the Earth did not rotate, air would circulate north-south, moving from the high-pressure poles toward the warmer, low-pressure equatorial region. Nevertheless, the Earth's rotation bends this airflow as it approaches the equator, creating a band 30 degrees north and south of it, called the horse latitudes. In this circumferential zone, air in the northern hemisphere deflects to the southwest, while air in the southern hemisphere deflects to the northwest. This band of westward moving air is known as the trade winds. Beyond its significance to pirates in the 18th century, the trade winds play a pivotal role in our story. As these winds traverse the Pacific Ocean, they drag warm water from the coast of South America toward Asia. The movement of warm water westward leads to the upwelling of colder, nutrient-rich water, a process vital for supporting phytoplankton, which sustains entire ecosystems of marine life. A disruption to this delicate balance would, therefore, have far-reaching consequences on oceanic life. Enter El Niño, the disruptor of normal conditions. During an El Niño phase, the trade winds weaken, causing warm water that would typically flow toward Asia to accumulate near the coastal Americas. This results in reduced upwelling of cold water and generates a zone of warm air and water further east in the Pacific. The decline in upwelling leads to migrations or mass die-offs of fish, affecting marine ecosystems profoundly. Furthermore, the Pacific jet stream, which typically crosses North America, shifts southward during El Niño. Consequently, the northern United States and Canada experience warmer and drier conditions, while the Gulf Coast and significant parts of coastal South America become wetter. Peru and Ecuador receive their wettest months from April to October, and in severe El Niño years, this can result in catastrophic rainfall and flooding. The 1997-98 El Niño brought devastating floods to Peru, causing the collapse of bridges and burying entire shanty towns under a meter-thick layer of mud, displacing 250,000 people. The region of Tumbes, usually arid, received an astounding 16 times its average annual rainfall. El Niño sets off a cascade of effects that significantly alter weather patterns worldwide. While South America witnesses increased rainfall, South Asia and Australia tend to experience pronounced periods of drought. India has recorded severe famines during La Niña events, and a delay in Australia's monsoon season can lead to devastating bushfires. The Australian bushfires, given the vast expanses of grassland, are among the most destructive on Earth. In 2020, a non-El Niño year, bushfires left 50 million acres of land charred to a crisp, creating nightmarish apocalyptic scenes. With El Niño on the horizon in 2023, Australia braces itself for potential challenges. On a global scale, El Niño raises the average surface temperature by 0.1 degrees Celsius. However, not all El Niño events are severe. Some can be relatively mild. The average duration of El Niño is 9 to 12 months, but on rare occasions, it can last for years. The complexity of Earth's climate system means that the impact of El Niño is best understood concerning the baseline conditions, explaining the variations in each El Niño year. La Niña, the counterpart to El Niño, represents a cool phase. During La Niña, trade winds intensify, causing more warm water to be pushed from coastal South America toward Asia, leading to increased upwelling of cold, nutrient-rich water near the Americas. This abundance of nutrients creates a feeding frenzy for fisheries, benefiting cold water species like salmon. Moreover, warm equatorial water flowing into Asia causes wet conditions and a spike in tropical cyclones. In North America, the jet stream shifts further north, causing drought in the southwestern United States and rains in the Pacific Northwest. The La Niña of 2022 exacerbated a megadrought in the southwest U.S., making it the worst in 1,200 years. The effects of La Niña on hurricanes differ regionally. The Atlantic experiences more severe hurricane seasons due to increased atmospheric instability in the South Atlantic during La Niña. However, the Pacific Basin witnesses fewer hurricanes. But this disparity should not lead to complacency, as El Niño has the opposite effect on hurricanes in the Pacific. The weather in Pacific coastal South America during La Niña does not exhibit the warm Christmastime waters that once earned the name, El Niño de la Navidad. Instead, it experiences colder and drier conditions, sometimes leading to severe droughts in Peru and Chile. Meanwhile, Brazil's northern regions witness increased rainfall during the months from December to February, and the lowlands of Bolivia may suffer catastrophic flooding. In Africa, the conditions during La Niña are essentially the reverse of El Niño. East Africa tends to experience drier than average conditions, while the southern regions often face wetter than average conditions. Now, you might be wondering about the current state of the ENSO cycle. As of the making of this article, the National Oceanic and Atmospheric Administration, NOAA, has declared an end to a prolonged 1.5-year La Niña. This conclusion is based on measurements of the Equatorial Southern Oscillation Index, EQSOI, which indicates a return to near-normal conditions. However, there are already signs pointing to a potential El Niño later in 2023. The NOAA forecasts a 60% chance of El Niño setting in by autumn. This could have significant ramifications, with India already warning its citizens of potential drought conditions. Considering historical data, there has never been more than a 4-year period without an El Niño event since tracking began in the 1950s. If 2023 does not bring an El Niño, it would mark the first 5-year gap without one. Such a phenomenon highlights the cyclic nature of ENSO and its enduring influence on our planet's climate. Studying and understanding climate cycles like ENSO are crucial for our survival and adaptation, not only on Earth but also as we contemplate the possibility of settling on other celestial bodies or even terraforming. As we dream of future endeavors on Mars, Mercury, Venus, the Moon, or beyond our galaxy, comprehending the intricate interplay of climate systems and biospheres becomes paramount. In conclusion, the El Niño Southern Oscillation is a captivating climate cycle that exerts a profound impact on our world. From its folklore origins to its scientific revelation, it continues to intrigue and challenge us. As we document the events of 2023, we add to our understanding of this enigmatic cycle and prepare for whatever the future may hold. Share your experiences of how El Niño or La Niña has affected your part of the world in the comments below. Together, we shall uncover the mysteries of our planet and embrace the resilience of life amidst its diverse and dynamic climates. Thank you for joining us on this captivating expedition of discovery. Until next time, may the light of knowledge guide your path through the wonders of the universe.